Hi, this is Austin. This is Lab 6 for hardware conversion classes. All right, in this lab, we're going to be utilizing a potentiometer to rotate a servo. And we are also going to create a separate module and import that module to use in our main code. Hey, this is Austin. This is Lab 6 for hardware. In this lab, we're going to be utilizing a potentiometer to adjust a servo horn to move it 0 to 180 degrees. We also create a custom module which I use to map all the ranges of the servo to convert it to degrees. And that is shown over here. All right, so on the right side here is the main code. We import all these different things, analog IO, pulse IO. Pulse IO is for the servo. Servo underscore remap range. That is the module over here on the left side of the screen. As I mentioned before, it handles all the conversions from the servo steps to degrees. Rest of the stuff utilizes Adafruit's motor library, servo library, and analog in. So we utilize analog in on A1. This is for the potentiometer. And then down here on line 16, we establish an object called PWM. And here we designate PWM to output to pin A2, which is connected to the servo. Oops. And then we use the standard duty cycle, which should be 20 milliseconds for the servo model. 50 hertz is a standard frequency. Line 17, we create a new object and we set it to PWM, and we can set minimum pulse and max pulse. These are how long each pulse will be. So we deviated a little bit from the standard with 800 and 2250. So the minimum pulse is basically 0.80 milliseconds. Max pulse is 2.25 milliseconds. And we deviated a little bit in an attempt to troubleshoot. This was found to be the most successful min and max pulse that we were getting the best results from. And then we set another object on line 20, angle equals 0. So we're going to be starting off at 0 degrees. And the while true loop is the main loop over here. This is where we call in our custom module over here, servo underscore remap range. And we call this function remap range over here. So with this code, we set the left span of the servo to be in this range roughly, 1.0 milliseconds to 1.25. Though with our code, we changed it a little bit. And the middle range is 1.5 milliseconds over here. And that will be the around 0 degrees. Let me walk back a little bit. This should be negative 90 degrees. It should be 0 degrees. And then to do our right range, we do 1.75 milliseconds to 2.0 milliseconds. And that'll be the 90-degree angle over here. So that is handled over here in our module over here. We take care of the left range in lines 9 to 10, and lines 12 to 13, we do our right range, package it all up, and then return the value. So what this does in the end is it maps up these 0 to 65535 steps and changes it to 0 to 180 degrees. And we have a little time sleep down here, and we set the angle and we print the angle. So let us see what it looks like. This is with the code, the serial monitor over here. And now we get to demonstrate the problems we have with the servo. It appears that the servo is a little faulty. It refuses to go beyond the 0 degrees to positive 90. Okay, So we have our servo over here. Over here this way is 0 degrees. This should be negative 90. And this should be positive 90. However, our code has it so this is actually 0, this is 90, and this is 180 over here. So keep that in mind. Right now, you can see in the serial monitor, we have it set to 176. We're going to turn the potentiometer over here, and you can see the horn moving to approaching 90. And as you can hear it, it's buzzing slightly. The servo refuses to move beyond 90, even though we attempt to with the potentiometer. Now, in theory, we should be close to 0 degrees, but the servo refuses to move. It's very finicky. It's heating up too. Okay, so let's go back to 90. It's very finicky too. Sometimes it would get stuck completely, and I'd actually have to hit the horn a little bit, and then it would unjam itself. So we're back at 180. And we get stuck. See, like right now, it's jammed up. I have the potentiometer set to 180, and it is stuck at the 90 degree. So sometimes you gotta walk it back to around 90, but it's still stuck. Let's try to give it a little tap. There we go. See, it unjammed itself. And now it's semi-functioning. It's oscillating really bad. Not that smooth at all. So I believe something is up with the gearing. Not entirely too sure without ripping this thing apart, but I've tried several test codes. Tried troubleshooting it, and it looks like the servo is possibly faulty. Oh yeah, it's starting to heat up a bit. So not a complete success, but overall it was a interesting troubleshooting. In conclusion, the lab was partially successful. The servo was able to move from 180 degrees to 90 degrees. However, the performance was inconsistent and very finicky. Importing the module and the code was successful as well. It allows encapsulation and to keep the code clean and simple. With the troubleshooting portion, I had to take a systematic approach. I ended up looking up data sheets for that particular model of servo, looking up the movement range, the duty cycle, and the minimum and maximum pulse lengths for that servo. And I tried adjusting each one of those variables and observing different results. However, the servo was very inconsistent. At times I would have success moving the servo, change one variable, and it wouldn't work, and then I would change back to the original variable and the one that worked, and it would just totally fail. So all signs point to a faulty servo, maybe a stripped gear or something is messed up on the inside. And that's about it. This lab is a little bit frustrating, but it was a good learning experience, especially with troubleshooting. Thanks for watching.